The equation of motion of a particle is given by s equals 2t cubed minus 5t squared plus 3t plus 4, where s is measured in centimeters and t in seconds. Find the acceleration as a function of time, and then what is the acceleration after 2 seconds? Remember that to get the acceleration, we have to take the second derivative of the position function, right? If we have the position function, we take one derivative to get the velocity function, and then from there, we'll need to take another derivative to get the acceleration. So let's start by getting the velocity function, and we get that by taking the derivative of the position function. This is a polynomial. We can differentiate each term one at a time, and I want to actually do all of this in one step. Let's see if we can do this. If we're differentiating 2t cubed, well, the derivative of t cubed by the power rule is 3t squared, and if we multiply 3t squared by 2, that gives us 6t squared. Then minus the next term, the derivative of t squared is 2t, and if we multiply that by 5, we get 10t, so that's going to be minus 10t, plus, if we take 3t, the derivative of t is just 1, and so 3 times 1 is just 3, so we've got plus 3, and then plus the derivative of a constant is 0. So this is our derivative of the position function, which gives us the velocity function. Now, if we want the acceleration as a function of t, we have to take the derivative of the velocity function that we just got. So, if we differentiate t squared, that's 2t, and 2t times 6 is 12t, minus the derivative of 10t is just 10, because the derivative of t is 1, 10 times 1 is 10, so we've got minus 10, and the derivative of a constant is 0, so this is all we have for our acceleration function. So this is the acceleration as a function of time, and we want to know the acceleration after 2 seconds, so that's going to be a of 2, so we just need to plug in 2 here. 12 times 2 is 24, and 24 minus 10 is 14. So the acceleration is 14. Now, the distance function was measured in centimeters, where t was measured in seconds. So distance is centimeters. Velocity is going to be centimeters per second. And acceleration is going to be centimeters per second squared. Whenever we have acceleration, it's going to be whatever the unit in distance is divided by the unit of time squared. So it's going to be centimeters per second squared. And so our acceleration function was 2t minus 10, and the specific acceleration after 2 seconds was 14 centimeters per second squared.